test corrections. For the first problem, I need to correct the number 6. The problem was to evaluate the equation limit x of 0 of x to the 6 cosine 5 over x. And in order to evaluate this, we will be using the squeeze theorem. Although first it would be useful to apply displacement, or direct substitution. And when you do that, you find that it does not work and simply results in a d/e, which then means to use the squeeze theorem. When using the squeeze theorem, there are 2 conditions that must be met. The first condition is to establish limits for it, and in order to do that, although some problems simply come with it, in order to find the one for this, we need to do a little bit of work. And to do that, first we need to find the limit of, or the boundaries of cosine 5 over x. And in order to do that, we can graph cosine of x, which looks like this, and have this limit of x equals 1 and x equals -1. And once you do that, so that means that the limits are cosine 5 of x is greater than or equal to -1 and less than or equal to 1. Once we have that, we can multiply by x to the 6 to get negative x to the 6 is less than or equal to cosine 5, or x6 cosine 5 over x greater than or equal to x to the 6, which fulfills con 1. For condition 2, we have to show that the boundaries are equal to one another, and we do this by applying the limit we apply the limit for both of them, find that they both equal 0, which therefore means that they're equal to one another, which fulfills condition 2. And with both conditions fulfilled, we can write the conclusion, which states, in conclusion, by squeeze theorem, we have to state how we solved it. Every time we don't use squeeze theorem when we're writing a conclusion. Right, in conclusion, by squeeze theorem, to the limit of x equals 0, x to the 6 cosine 5 over x equals 0. The mistake I made when I was doing this problem on the test was I simply used direct substitution at first and didn't go any further after getting a d/e. Now for problem number 15, which was finding the velocity finding the velocity using the displacement equation s equals 2 over t squared. The points t equals a, 1, 2, and 3. In order to solve this, we can use the definition of derivatives. So we can use this definition, lim h to 0 equals, lim h to 0 s a plus h minus s of a over h. And when we use the actual equations, that works out to 2 over a plus h squared minus 2 over a squared all over h. After this, in order to combine these two, we have to multiply the numerator and denominator of both equations by the denominator of the opposite one, which results in 2a squared minus 2a plus h squared all over a squared times a plus h squared all over h. And then simplifying from there, you just continue to simplify for a period. And once we're at this point, we can get rid of the h in the denominator by multiplying the numerator, this, by 1 over h, which results in at the same time, we can take the h out of the numerator by doing this. I just made a mistake. I accidentally used a plus instead of a minus up here. Writing -2, my mistake. After we have this, we can go ahead and apply the limit, which results in -4a over a to the 4th, which can be further simplified to -4 over a to the 3rd. use this equation for the other problems as well, for the other values as well. So for t equals 1, we get when I was solving this problem on the test, I made the mistake of simply dividing 2 over t squared by t in order to get the velocity, since it said it was displacement, which did not work. Then I had simply applied all the values to that, and that did not work. Thank you for your time.